All right, hello everyone and good afternoon. We hope that you've been having a great weekend so far. My name is Riya Gupta. I am a grade 12 student and I am president of the Project Pulse Winnipeg executive team this year. So Project Pulse Winnipeg is a nonprofit, youth-led organization, and our goal is to familiarize high school students with the field of the health sciences. In the past, this came in the form of an annual, in-person, day-long conference. But with the emergence of the pandemic last year, Project Pulse Winnipeg switched seamlessly to an online platform, continuing to bring students events, resources, and opportunities for health sciences education. All of the executive team roles are filled with passionate and hardworking students from diverse cultural and academic communities in Winnipeg. And some of them are in the audience with their cameras on. Maybe give us a quick wave. Thanks, everyone. All of these roles contribute significantly to Project Pulse Winnipeg in unique ways, and they helped plan this professional panel. So today, our Professional Relations Director, Vicky, will be hosting this event. On behalf of the team, I'd like to extend a warm welcome to our audience, which consists of high school and post-secondary students from all across the province. We encourage everyone to have their cameras on for the best experience of engaging with the professional panelists, but it is not a requirement. Please note that this event will be recorded and the recording will be posted on Project Pulse Winnipeg's online platforms. This includes social media and our website. Please fill out and return the waiver attached to the email you received this morning to confirm your consent to be recorded and posted as a part of the video. If we do not have your permission to feature you in the video, you do not need to turn on your camera and you are welcome to engage through the chat function instead. So without any further ado, I will hand this off to Vicky to introduce herself and today's distinguished guests.
Thank you, Ria. So hello everyone, my name is Vicky. I'm a grade 12 student and also the Professional Relations Director. So we are so incredibly excited to be able to host a panel today regarding research that is happening currently. And I'm honored to introduce our esteemed panelists for today. So this research is organized by Dr. Tanveer Sharif, who is one of our panelists today. And he's an assistant professor in pathology at Rady Faculty of Health Sciences. As a pharmacist turned researcher, he received his bachelor's in pharmacy and master's in pharmacology. Dr. Sharif completed his PH.D. at the University of Strasbourg in France before moving to Canada in 2013 to pursue his postdoctoral fellowship at Dalhousie University, where he trained under the supervision of Dr. Patrick Lee prior to his retirement. At Dalhousie, Dr. Sharif studied the role of tumor suppressors and metabolism in embryonal carcinoma stem cells and patient-derived brain tumor initiating cells. In 2019, Dr. Sharif joined the U of M as a principal investigator to lead a new tumor suppressor biology, autophagy, and metabolism program in the Department of Pathology. Today, we are also honored to have with us two individuals, Emma Martell and Helgi Kuzmychova, who work on this research project with Dr. Sharif. So Emma Martell completed her bachelor's in microbiology and immunology and master's in pathology at Dalhousie University in Nova Scotia. She is currently a third-year PhD candidate studying at the U of M under the supervision of Dr. Sharif in the departments of pathology and human anatomy and cell science. And last but certainly not least, we have Helgi, who is an international student from Ukraine. She finished a biotechnology bachelor program at the University of Wrocław, Poland, and after a short working period in experimental endocrinology in Ukraine, she came to Canada to further extend her field of expertise. She is currently a fourth-year undergraduate student in the genetics program at the U of M and is working on Dr. Sharif's research project. So with that, I'd like to hand it off to our panelists to begin their discussions. After the discussion, we will have time for pre-prepared questions and for the audience to ask any questions that they have live. So with that, take it away.
Hi, everyone. I guess I can take the lead to start in here. So thank you so much for having me. on this panel. It's a first of kind experience for me. We've been talking to like a scientist a lot, but talking to high school students is a unique experience. Even though recently I started having high school students in my lab. So it's a pleasure to be with you this evening. So I guess in terms of introduction, Vicky has introduced quite a bit about me already. So I don't know like what else I can add into that. But I can start with just a little bit of keeping in view the purpose of this gathering. I can just tell like a bit about our research, that what we are recently doing, what's the scope of our research, and what we are trying to cure, in fact. So I was not like a scientist with a motto to become a scientist. I didn't have a motto. I didn't have a plan right from the get-go to be a scientist. In fact, by profession, I'm a pharmacist. But after graduating, I started working as a pharmacist, but I noticed that job is not very thrilling for me. I want something like a career which is full of drama, challenges, and it has some thrill into it. So research is just like a perfect job for a drama and for lots of challenges, and it's full of thrill. Lots of failures, but when there is a success, that gives you like a feeling of euphoria right away that you ride on for a long time. So I worked as a pharmacist for a few years, but then I said, no, this is not the career that I want. So I pursued a master in pharmacology. So after doing master in pharmacology, I moved to France, and there I did PH.D. from University of Strasbourg. Previously, its name was University of Louis Pasteur. So there I not only did my PhD in pharmacology, I had the opportunity to learn French. French is a very sweet language. I hope few of you might be speaking French and they know how good is the French language is. But after working with French people, I really developed my research attitude. And in France, they say bon weekend. Bon weekend means happy weekend. So their research tempo was like a very different from North America. These people, there's much more relaxed environment. So I thought that, well, research is okay, it's keep going, but I didn't knew that what lies ahead of that. And after working with French people, I got the impression, I'm not saying that French people are bad, don't take me wrong, I'm saying that they are relaxed people, right? So, but I learned French. I consider French as my second language. I love French. So then I moved to Canada in 2013, and that was a huge switch. In Canada, research was totally different. My mentor, Dr. Patrick Lee, I worked with him like almost 5 years. So it was a 180-degree shift. He was a guy super hard, but very successful mentor and very successful scientist. He is the guy, let me tell you, right now for head and neck cancer, for the treatment of head and neck cancer, we use a virus that is called the reovirus. We give that virus to the patients of head and neck cancers, and there is dramatic recession of that cancer. So that reovirus right now is in clinical trials, not in clinical trials, it has been approved to be used on head and neck cancer. And the first person who find out that the reovirus can be used to treat head and neck cancer, he was my mentor, Dr. Patrick Lee. So you can imagine that how big scientist he is, that his discovery right today is being used in the clinics. So his discovery is touching the life of hundreds and hundreds of patients. In North America, reovirus is a part of standard therapy to treat. And what he found, that reovirus only kills cancer cells, not the normal cells. So I worked with that guy. So you can imagine the guy which has such a big discovery on his record, he must be having like high standards of like research. So then I had to change my French style of research to North American style. You have to work day and night. You have to work hard. But I was proud that I was working with Dr. Patrick Lee. And in his lab, we were able to publish several high impact research publications, research manuscript. We did like quite a bit of good research work under his supervision, but I was able to learn a lot under his supervision. And in fact, after working with him, I decided to choose research as my career for the rest of my life, because I really enjoyed the way he do the research. And I see him, like most of the time, he is just to the point. He will not talk to you much. He will ask you the questions straightforward. But when there is a discovery in the lab, I see him that 70 years old scientist, he was jumping like a high school kid, because he's a discovery. And I want to enjoy that thrill, that what get him so excited. Whenever there is some like good finding in the lab, he is jumping like a high school kid. You can see, and he don't get tired then. So I want to have that kind of career, that career where you have challenges to overcome. And then once you made some discoveries, they drives you like in a euphoric condition of the mind. So yeah, so working with that guy, with my mentor, Dr. Patrick Lee, it was really a game changer in terms of my career. And due to that hard work that I put in his lab, I got offer like to work as an assistant professor at University of Manitoba. But at that time when I joined University of Manitoba, I had options, like offers from a couple of other universities. And I dedicate all that success to my mentor, that a great person who made us work hard. We learned a lot from him. So I started my research lab here in University of Manitoba in 2019, August 2019. And few months after I joined, we had the pandemic. COVID-19 came in. So that was another big challenge, because for a person like me, when we start a new lab, you need to build lots of resources. So that was a huge challenge for me right from the get-go, because pandemic restricted our personal capacity, that which was we allowed to have in the lab, restricted many operations. In fact, we have to close our lab for 2 months because UVM was closed totally. So it was not a good start for us. But I was so lucky to have excellent people in my team who worked just like, I can't ask better people than them. And I think due to their untiring efforts and due to their very professional attitude, soon the pandemic was a little bit, like things would start settling down. We had a flying start in the lab. So one of the person that I am always thankful for that was my first PhD student, Emma Martel. She is just like, she moved with me from, she was a master's student in the Dr. Patrick Lee's lab, and she was working under my supervision there also. When she found out that now I'm having my own lab, so she moved from Halifax, we were in Dalhousie University, to here UVM. She liked the research program that I had in my vision. So she came with me and she did an excellent job for the settlement of our lab, those early days. And once our lab was settled, then we started like recruiting multiple different students at different levels. We had students from like second year, third year, fourth year of bachelors from the university. So now we're recruiting even more people, like more PhDs, more master students. So I think that was a kind of brief introduction about like my path to the research. And now I would just like to touch up a little bit about our research. So at UVM, our research is mainly focused on brain cancer. So we work on brain cancer, and in brain cancer, we work on both like adulthood cancer, which we called glioblastoma, and childhood cancer also, that we called as medulloblastoma. So in our lab, main focus is on both these cancers. So what we are really interested in the brain cancer, why we are interested. So if we talk about the adulthood cancer, brain cancer, I can easily qualify to say that brain cancer, adulthood brain cancer, glioblastoma is the most lethal cancer. I think it's a number 2 after pancreatic cancer. So it's such a lethal cancer that the 5-year survival of patients in Canada is less than 5%. Once the prognosis is there, once the patient has the prognosis of glioblastoma, so 5-year survival is less than 5%. So 95% of the patients, they succumb to this disease within 5 years after the diagnosis. You can imagine that how aggressive and how lethal is this cancer. So that is one of the reason that we are motivated to work on this cancer. And what we are doing in our lab, we believe that to make glioblastoma or adulthood brain cancer cells such aggressive cancer, they should have some help from the metabolism. Have you seen like a 100-meter Olympics competition ever in your life? You see how fast those guys they run. They need energy. So we believe that the way these brain cancer cells, adulthood brain cancer cells, they run crazy. Within 5 years, they just take the patient down. From where they get such energy? They should have some support from the metabolism. They should have some special metabolism. They should have some ability to maneuver the metabolism in such a way that perhaps they are consuming all the resources of the body, all the important, metabolic components of the body. So that's our simple hypothesis that is driving our research. That we think that, well, these cells, these brain cancer cells, they are not running a relay. They are not running a marathon. They are running 100 meters. They want to finish the things quickly. And we want to find out what is helping them to run this 100-meter race successfully. And we believe that is metabolism. They hijack our metabolism. They change their metabolism in such a way that they successfully run this 100-meter race, and they take down the precious lives. So that is the main focus in our lab, that we wanted to understand what is special about the metabolism of those brain cancer cells. We want to understand that. And then we want to devise strategies to target those metabolic changes that we identify in them. And let me tell you, we are super thrilled by the findings that our labs has so far. We believe that we have found out some unique metabolic changes in those cancer cells. You know what? The relapse of cancer in brain cancer is almost 100%, I will say. 100% of the patient in brain cancer patients, glioblastoma, they have relapse. Cancer come back. We give them chemotherapy. It looks like cancer is cured. But within 15 months, not 15 years, within 15 months, this cancer comes back. And what we have found, the cells which have been treated with chemotherapy, the treatment which is used in the clinic to treat this cancer, changes the metabolism of those cancer cells big time. Soon those cells, they get some chemotherapy, that any treatment that is used in the clinical setup, those cells quickly change their metabolism. Let's say before treatment, they were using a certain metabolic pathway. I will not tell the complicated biochemistry, don't want to discourage you guys, at this moment. We'll keep things simple. Let's say before chemotherapy, they were using a kind of metabolism, and that metabolism is a metabolism A. Right after completing the first round of chemoradiotherapy, we see that those cells, they don't use that A anymore. They switch to a total different metabolic direction. Why they do that? Does that change in metabolic direction helps those cells to come back, cause the relapse? I think we have found something very interesting, that there are certain metabolic enzymes. If we block those enzymes in combination with chemotherapy, if we target those metabolic pathways in combination with chemotherapy, we can better kill those brain cancer cells. So this is what we are proud of. We believe that those findings will help to generate novel combinatorial strategies. We believe that targeting metabolism in combination with existing chemotherapeutic strategies will prolong the patient life. So that's a major angle in terms of glioblastoma brain cancer that we are pursuing in our lab. So other side of the brain cancer, medulloblastoma. In that cancer, my lab, there are 3 to 4 main groups of medulloblastoma. And those groups, they have different levels of prognosis. Some, they have good prognosis. Other groups, they have worse prognosis. In my lab, we are targeting the group 3 medulloblastoma. It's a cancer of childhood. And prognosis for that is about 60% of the patient, they survive. And remaining 40% of the patient which diagnosed with that cancer, they die. So that group 3 is the most aggressive in terms of medulloblastoma. So our lab, again, we are focusing what is how we can target metabolism in those childhood cancer. So recently we finished one animal study in our lab. We use mice, and in those mice we transplant childhood brain cancer group 3 cells in them. And we tested a compound into them, a compound which can target their mitochondrial metabolism. In that group, we have screened out multiple metabolism-based drugs. And what we have found, the drugs which affect their mitochondria, they are very effective in killing those cells. So we have done this experiment in mice. That's a preclinical study that you guys can say. And what we have found, that compound has dramatically decreased the size of brain tumor in those mice, and significantly increased the survival of those tumor in comparison to the mice which were our control mice. They were not getting any treatment. So just yesterday, I was discussing those results with one of my colleagues, our departmental head. And we were so excited from those findings that we are already thinking that we will do some plan to test those compounds in the clinical setup. So based on that finding, we believe that our finding can lead to add a therapeutic option to treat medulloblastoma patients. We have finished kind of preclinical, like a lab-based study, that this successful in animal experiment has given us lots of confidence, and we are already thinking about some clinical trials to test that in the clinic on the patient. So the research that we're doing, initially it was just like, to be honest, it was just like a career, to build a career. But now, after seeing those findings that we believe they may translate to clinic, now it has turned into a passion. It looks like that we are going to do something which is just like, it has the potential to touch the life of thousands. So that's all about, I will say, a brief, very simple summary of our research program. And I guess now my students, they will talk. So without those students, those like enthusiastic researchers, young researchers, I think these findings would have never been possible. So thank you so much. I will definitely have your questions when the time comes, but I appreciate this opportunity to talk with young minds. Thank you.
I guess I can go next. So as you guys already know, my name is Emma Martell, and I am a PhD student in Dr. Sharif's lab. And I have been working with him for, it's been, I think, 7 years now or more than that. It's been a long time now. So I started working with him actually in my undergrad. I did co-op and honors under his supervision back in Halifax in Dr. Patrick Lee's lab, and then started my PhD here in his new lab. So basically, I grew up in a small town in Nova Scotia. Well, actually a bigger town. There was about 8,000 people or something, but still smaller than some areas. In my high school, it was a combination of a junior high and a high school that altogether had about 500 students and less than 50 people in my graduating class. So I didn't really know a whole lot going into high school, what kind of career options and things there were available at that time. So like most of you probably are thinking, I kind of gravitated towards the field of medicine. You know, people used to say, you're smart, you should go and become a doctor or something like that. So that's kind of just what I had in my head leaving high school and going into university. And I tried to, you know, plan my academic career around that, going into the programs that I thought would best set me up for before going into med school and everything. But that quickly changed in around my third year of my undergrad. So I was pursuing a co-op program, thinking that it would be a great opportunity to get some, you know, experience in the health field, and you know, would look good on my CV and everything, and then I wouldn't have to go home and work part-time at Tim Hortons again over the summer. So I was pursuing a co-op job, and I applied to multiple different places in Halifax, all of the opportunities that were available, and I got denied from every job. And so I didn't think I was going to end up doing any co-op work term. And then my co-op supervisor got in touch with me and said there's a research lab at Dal, and they're looking for an undergraduate student to help out. You can start, you know, volunteering and see how you like it, and then maybe it will become a co-op job for you in the summer. So I said, that sounds great. I'm really interested. And then I went and I met with Dr. Sharif in Patrick Lee's lab. So he was doing his postdoc at that time. And we sat down and we talked, and I was really excited to, start in the lab. I had no idea I didn't know anything about lab work or what it would be like. Working in a research lab is very different from your teaching labs that you do in high school or in university. It's not the same at all. So I really came from nothing and started in there. But as soon as I started, it was with research and the lab environment, and it was just very exciting. Working on the bench and everything and getting new results, it was all very exciting. I remember one thing that Patrick said to us one time when he was in the lab that day. We were talking about some new data and stuff that we had found, and he said, "Isn't this so exciting? You're the first person in the world to know this information." And I said, yes, that is something that's very exciting, like being the first person in the world to know anything. That's pretty phenomenal feeling. You can learn a lot of stuff from books and things, but the things that you learn in the lab doing research, you can't learn that from a book because you're the first person to really discover it. And maybe someday they'll be teaching about it in textbooks or things, or it will be in clinics. So that was something that was really exciting. And basically after that, I never looked back. I didn't even think about writing my MCATs or anything like that. I had fallen in love with research, and I became determined that that was the career that I wanted to go, even though I knew it was a bit of a harder path. A lot of people have this misconception that doing a master's or PhD or something is for the students that couldn't get into med school, or they failed and they couldn't become a doctor, so they're becoming a PhD. Kind of a joke that some people say, but I don't find that to be the case at all. If you want to really be successful in research, you have to be very committed and dedicated to it. And it's not something that you just kind of pick as a option B, because really it is the same, if not longer, amount of time that you're going down this path. Once you complete your undergrad, your master's, PhD, postdoc, you're putting in about the same amount of time as it would take to do a medical degree and your fellowships and things that follow that. But in the end, you're not always guaranteed a job. If you're a doctor, you're going to get a job anywhere in Canada. And depending on what you specialize in, you might even be more in demand than others. But there's really no shortage of doctors, or there's a shortage of doctors in Canada, so there's no shortage of opportunities. But for researchers, it's a little bit different. The competition is very high, and you really have to be dedicated and at the top if you want to go all the way. Lots of people, they do their PhD and everything, and they want to go into academia, but it's not always possible. There's very limited positions, so they may end up working in industry or something else that may not be what they planned. But if you're really hardworking and passionate, it's a very exciting and very rewarding career that you can pursue. But it is a lot of work, and it is definitely a difficult path, but a very rewarding path. So I I'm currently in the PhD part of my journey. And so I still have a bit of a road ahead of me, postdoc and everything before I can possibly look into applying for any academic positions. But so far, I think I've been very lucky and very blessed to have had a lot of success so far. And I attribute a lot of that to working with Dr. Sharif. He's been a really great mentor and supervisor. So we've been working very closely together, and we collectively, we were able to publish a lot of great findings and everything from our previous lab. And I was very proud and honored to be a part of those studies. And now I think we're working on even more exciting things that Dr. Sharif was sharing with you. Like those are really, really exciting projects. And I, I think back to what Patrick said, when we had the results from our recent mouse study, it was very exciting. And we really are the first people in the world to see that this compound can treat those types of brain tumors in mice. So it's that kind of, makes all of the struggle and the difficulties worth it in the end. And it's those types of findings and things that really keep you going and motivate you to keep going forward and working hard. So yeah, so my future is looking pretty good right now in terms of what we've been working on in the lab. I'm really excited about that, and I hope that they will lead to very big and significant findings and impacts for patients. And I want to continue doing that for the rest of my career. So we'll see how things turn out, but this is the stage that I'm at right now. Yeah, so I guess, Helgi, you can go ahead and share with everyone.
Okay, hi everybody. As it was mentioned, my name is Helgi. I'm an international student, so well, my background and story may be quite different, and I don't know how much my experience may be valuable, but still I would like to share it. So back in Europe and Ukraine, I would say all the way we look on education is slightly different. It's a bit easier to get in your master's and even to do PhD, though you can't change your degree whilst you studied your education. So pretty much you go to the university with the knowledge that you are going to become a particular specialist. You always can abandon this and like give up what you're studying right now and start from scratch in a new program. But you should know from the very beginning what you're aiming for. I guess, yes, as many kids, when I was in high school, I was thinking about medical school. But at the point, I was kind of maximalist teenager, and I was like, I want to be a surgeon, and I'm not interested in anything else. On which my parents said, like, no, you're not going to be a surgeon, and it's our last word. So then I said, okay, I'm not becoming a doctor at all, because if it's not for surgery, I'm not doing it, which now I find quite ridiculous, but whatever. And then I said, like, okay, if I can't be a doctor or surgeon or whatever, I want to be a researcher. Yeah, at the point, I didn't quite understand what it means, but it was my intent from the very beginning. And for some reason, I thought that biotechnology would be a good beginning. My understanding of what biotechnology is, what's very unclear at the point when I was deciding which program to go to. But like, I thought that it should have something with developing things related to maybe medical technologies or some technologies, right? Bio and technologies. Well, when I started going through my degree, I pretty fast understood that it wasn't quite what I expected to have. because it was more about working in the industry, using technologies to work with my molecular and bacterial cultures. And like, pretty much you can say that production of any dairy product can be named biotechnology at some point. So I should say it wasn't what I wanted to do. And I was like, I don't want to be in industry. Yes. I was quite lucky to get some volunteering when I was studying back in Poland. It was in the immunology institute. Surprisingly, we were working on genes determining the sex for bees, which was interesting from a point of view that I got quite some practice on techniques which I was taught in the university, but it wasn't very thrilling, partially because we didn't get much of an insight on what we're working for. It was pretty mechanical work. So I will come, I will do some experiments, I will give my data. Very often I will be told, you screw everything up. I'm sorry, it's not working like this. And I'm like, okay, I will repeat it tomorrow. And it can go like this for quite some time, it wasn't very exciting experience. And at some point I was like, okay, I guess I will go away, guys. Like when they said that like maybe you want to proceed with masters, and I was like, no, I don't think so. So I got my bachelor's in biotechnology and went back home and got some more experience in a lab back in Ukraine, which I should say was even more exciting, because unfortunately in Ukraine we didn't get any funding at all, and even though our projects were interesting, without the funding it was impossible to proceed with any research at all. So I decided to continue my education. Unfortunately, I wasn't able to continue with a master's in Canada, but I could have started with bachelor again, but override some of the courses, saying that if I already took them, I don't need to repeat them again, which was a huge benefit for me and allowed to skip me at least majority of entry courses in the university. And then I was extremely lucky because one of my professors on human genetics was providing us with a list of professors at the U of M looking for undergraduate or graduate students or anybody interested in volunteering or becoming a master's student. I should say, like, here, at least the course on human genetics where all this was advertised was taking like 60 people, and the list of professors was rather short, like 10 or maybe 12 people. And I was like, okay, what are my chances to get any position, like even volunteering in any lab? I thought the chances were pretty much zero, but I still decided to write to Dr. Tanveer because, we were provided with pretty short background. I looked some more papers. It all looked very promising. Well, I didn't have much hope, but still I decided to write to him. And I was extremely surprised when Dr. Tanveer answered that he would like to have an interview with me, and then gave me a position as volunteer. I should say that comparing to how I was treated in Poland, my experience got extremely different. I was given like some of my personal space, like I have my desk in the office. I can have some hours to go and study. I was given lots of insight on our research, what we are doing, why we are doing, how the data I'm providing is used. Overall, of course, like right now, my volunteering, like after volunteering, I got a working term through the summer, and now I'm going on with a honors project in the lab. Like, but still, maybe when you just look at how I'm working there, it may look like a pretty straightforward routine. I do some experiments, which is pretty much mechanical work, right? You just need to do it more or less, like you need to be accurate, careful, you do it, you are good. But when you know why are you doing it, and I feel like my purpose is to produce data, and this data later on is utilized to make something new, unique, to figure out things. And when you start to understand why are you doing this, it's becoming so much more important. It's like you got your purpose, and now you know what you're moving for. And sometimes when I look in the research community, it's absolutely fascinates me, because when we're doing some research, we usually we look for papers which will controverse our data or will go along with it. And it's absolutely amazing how I may use papers wrote by some guys in London or, I don't know, in Europe or in Australia. I would never see these people, but their data help me. And then I think that data which I'm producing and which our lab will publish will be used by somebody else to compare results at least. It's so amazing because right now, the amount of data produced and analyzed by different various labs over the world, it's tremendous. And if we can get use of it, we can utilize it. We can come up with absolutely incredible findings. And when I think about it, I'm just getting so inspired. And so I may do my routine, but I'm doing it. I'm like, oh my God, I love this work. I want to do it. It's just an amazing feeling. And I'm so happy I got this experience and such a treatment. I guess I'm lucky, but I believe that if you put enough of effort, you may find something you're interested in and you can get a position there, you can try. You may find that it's something not what you expected, and it's okay. Even if it's not what you wanted, you just may try something else until you find what is really yours. Because when you are driven by the work you are doing, it's the best way to go on. Well, I believe so. And I hope that I will be able to stick with this field and that my academic career will go well. And I'm ready to put lots of effort into it, because now I'm sure that it's what I want to do and I want to work in this field and I want to go on with it. Yeah, so thank you very much for your attention. And I hope this small insight will be somehow vulnerable and helpful.
Yes, definitely. Thank you so much to the three of you for your extremely educating and inspiring discussion. So now we'll be moving on to our questions and answers period. So prior to the event, panelists submitted any questions they had for our panel. Sorry, participants submitted any questions that they had for our panelists. And if any of the participants have any questions right now, feel free to put it into the chat and we'll get to them as soon as we can. So our first question is from a grade 12 student who asks, do you have any advice for university or high school students who want to get some research experience? So this isn't directed to any one of the panelists. Any one of you can answer, or you can all answer this question. It's up to you.
I guess I can take the lead onto that. I'm sorry, you may heard some background noise. My family, my kids, they're kind of protesting that I'm working over the weekend. Normally, they don't like it. So my advice would be that, getting a research experience, no matter what you want to choose as your career, regardless of your choice, I think getting a research experience is very valuable. It's extremely valuable. It open up your vision, right? You see things live happening, research, the environment of research, and you get some direction. So I will say it's very important and it's very healthy activity. So if you want to ask how you can get that, I think there are multiple ways to do that. You can reach out to, at UVM, especially at Radial Faculty of Health Sciences, We have like multiple departments: pathology, physiology, pharmacology, biochemistry, etc. Reach out to the people, and normally in summer, they are flexible and they will provide you an opportunity to work with that. And if you are in a university already, same thing. A university, there are some scholarships that university offers. I think there's quite a bit of scholarship. I think it's about, my students can correct me if I'm wrong with the number. There's about, I think, a couple of thousand scholarships like every year they offer for like a university students to go in a lab and get, it's a summer term actually. It's a paid summer term through the UVM, and you can benefit from that also. There are multiple opportunities once you are in the university. But if you want to have while you are in a school, I think the best way is to just send an email to those guys, those researchers, introduce yourself, etc. And they would definitely be, they will help you with that. I hope I answered the question, but my students can add.
Yeah, I also just wanted to add that on the university, for every department, there is some list of professors, usually with short background, and very often it is indicated if a professor is interested in taking any volunteers or undergraduate students in their lab. And yeah, I guess reaching out for them is a straightforward way to get some position.
Okay, thank you so much. So our next question is from a grade 11 student who asks, what skills have you found vital to your job? And as a follow-up, what skills have you gained or learned during your research time?
I think maybe the first part is related to me because it's related to job. I guess like for a researcher, like Emma and Helgi, both of them, they mentioned commitment and dedication. That is the most valuable skill that a researcher acquire while he is in the research. If you are not dedicated, if you are not committed, I think research is not the field that you want to. Being a doctor, like being a physician, you sit in your clinic, 10 patients waiting outside, one by one, keep coming in, you finish 10 and you are done, right? That's a total different commitment there. But being a researcher, you have to face the failures. You have to come with a plan to overcome those failures, challenge, right? So I think the skills that I acquired being a researcher is like commitment and dedication. How to remain committed, how to face the challenges. So, and those are the like skills, like my personal skills, like, and if you ask me skills in terms of technical skills, there are a lot that I think might be, they come across like, many things that you learn over the time. So rest, I think Emma and Helgi can elaborate.
Yeah, sure. So definitely hard work and commitment. Those are two major ones. And then I would also say the ability to adapt, adapt to, like Tanveer said, any failures or road bumps along the way. Research comes with a lot of ups and downs. You get, you get a lot of excitement when you get good results, when you finally get your paper published. But on that journey, there's a whole lot of obstacles in the way, lots of experiments that didn't work. Your funding being denied or your scholarship not being accepted, you're submitting your manuscript to a journal and it comes back rejected, reviewer comments. So you have to have a bit of a tough skin and ability to just kind of keep moving forward and keep working through that. So I think that was one big thing that I learned, because I remember when I was younger, I used to take things quite hard, especially failure and things. But now I kind of just take it as an opportunity to do better and, show that I can still, be successful and do the things that I want to do regardless of these setbacks. So that's one major thing. You have to have a bit of tough skin to be in research. And in terms of technical skills, you're constantly learning new things in research. There's always new techniques coming out, and it's really exciting to, read someone's protocol or something. It's great if you can learn it from someone, but that's not always possible. So sometimes you have to teach yourself how to do things just based on a written paper or something. So that's always exciting to learn new things. And it can take some trial and error, but to learn those new skills and things, it really helps you grow and keeps you on top of things as you keep moving forward.
Well, also about some unexpectedly needed skills for such type of work, which I found, maybe it's me because English is not my first language, of course, but you need quite good writing skills because you need to be able to describe your job in a pretty straightforward, understandable, but also like proper and nice way. And I'm working on it, but it's a bit more complicated than one may think. And also, as I'm still learning all these techniques, it's very important not only to be able to overcome some of your failures, but also to find the root of your mistake and do your best to resolve it. Because if it was your mistake, you need to find out how not to repeat it. And I would say it's applicable to learning any new skills, technical or not only technical. But here, maybe it's a bit more important because if you fail in some of your experiments, there is no way you're going on without them. Most probably it will mean that you will just need to repeat them, but repeat them without flaws this time. Yeah.
Yes, thank you so much for just talking about like fallbacks and just challenges you faced. I'm sure that's the insight you brought from that is very inspiring. And just kind of as a follow-up question or just something related to that, we have a question about what are some examples of fallbacks you have faced during your research lab as a team? So you've discussed like personal challenges, but what are some of the biggest fallbacks you have faced as a team for the research project? And how did you recover and move on from these fallbacks?
Very interesting question. So fallbacks, I don't want to scare you guys at this moment, but in research, out of 10, we have 7 fallbacks, 7 things which don't go as we planned, and we have only 3 success. That's like normal rate of success. But those 3, when you have those 3 success come your way, you forget those 7 setbacks, because like I mentioned in the beginning, they drive you like in euphoria, because success in research is huge. So just to give you some examples, like that's the question which was asked. Sometimes what happens, research is driven by a hypothesis always. We always have a hypothesis in our mind that we believe that when we do this, the possible consequences would be on the right side. But when we do that, we say that possible consequences is neither on the right nor on the left. It is present and in up actually. And that's, kind of, it's a shock for the whole team. Why? Because they have spent their resources, they spend their time, they have to revisit everything now. They were thinking that, well, after this treatment, things will start going towards the right. But instead of right, they don't even go towards the left. They go in the up. Okay. So those are like the failures. Those are the challenges that we face. And to be honest, in the beginning, when a new researcher lands in the field of research, in the beginning, we always take those setbacks to our heart. But then we get used to that, because we tell ourselves that as far as we're committed, to do something great, let's take this failure like to our with a smiling face, that we will face it. And just if you want a particular example that of our failure, We were doing a project just like, I will say 3-4 months back, we had a data. We were expecting that after giving certain therapy, there are some enzymes which change, and we were expecting that those changes in the enzymes, they will drive the mitochondrial function. But we saw that those enzymes, they are coming up, but there is no change in the mitochondrial function. And those enzymes, they are linked with mitochondria, and it drives you crazy. Well, these enzymes, they are linked with mitochondria, and they are changing a lot. They are increasing, but mitochondrial function is not. We were surprised. And I was, what they are showing to me is not possible. But then some competent student, like in that case, it was Emma, she went and she said, well, let's try to read what is known about those enzymes in the literature. And they found out that it is possible that those enzymes, when they are increased, they can go to nucleus. And they can do some like something related to DNA. And we said, well, let's check that. Maybe in our case, this upregulation is doing that. It drives open new door for us. And it turned out that our enzymes, now we did some follow-up experiments. In fact, they're going to the nucleus. So there was a failure, which I was upset. And when the students were talking to me, I was saying, what they are talking? These enzymes, they're mitochondrial enzymes, But then suddenly she came up with this idea. We checked that, and it was true. Now we have a novel things going on. So that's a classical example that you want from me as a failure. But as a team, what we have learned, that we don't get disheartened very much. We regroup. We said, let's think about it. Let's talk. Okay. And that's, I think, the power of our group. I think most of the research groups, their style is same, but I'm not sure that all of the people, they do like this. Our strength, especially in my lab, that every morning we all sit together. And whenever there is some exciting thing, I ask all my students, come, have a look. They get excited. They see it. Oh my God, what is this going on? So yeah, there are failures, but we have come a long way, and we know how to overcome those failures.
Okay, thank you so much. It's definitely, it's really important that these students hear your words, because it's very important that you know how to work as a team and kind of just move on together from setbacks and just kind of work through it. So our next question is from a grade 10 student who asks, how do you decide what you want to research?
I guess I will let students to answer this question, because they would be more. But in my case, I didn't like being a pharmacist, dispensing medicine. I'm not saying pharmacy is a bad profession, it's a good profession, but perhaps there are less challenges in there. So this is how I shifted towards the research. But Emma and Helgi, I think they can add better.
Yeah, I think with a lot of students, when you start really early on in your undergrad or something, and you're interested in getting into research, you just sort of start researching in whatever opportunity you can find available. So I was very lucky that I started out in a cancer research lab, and I found that very, very interesting. And that's what I wanted to keep researching. Some people, they may start out in one lab and feel like that might not be the area that they are interested in, which is fine. But I think a lot of times when you're starting later on, if you're going towards masters or something, and you're trying to pick a supervisor or a lab, you can go and look up various professors and things at different institutions and see what kind of research they're doing and whether that appeals to you, if it's suitable for your background and things, and then apply with them. But again, there's limitations into people that are hiring and things. So So that's how you kind of get into the lab, and then to decide what you want to research once you're in the lab, it's can be difficult. I think that in our case, we, especially since Tanveer and I came from the same lab and the same background, we were able in this new program to really jump into our research projects. It took a while for us to get the footing of what we wanted to look at, but because we kind of had that same working background and everything, we were able to, once we started getting some good results, we were able to get our direction pretty well. But it's a problem that a lot of researchers struggle with, is trying to find a new topic or something, a new angle to pursue. So I think you just need to really read what kind of research is out there, and see what people are doing around you in the lab, and use that to form hypotheses. And then once you have some preliminary findings, building off of that and finding the direction. Again, it might not be what you're thinking, but those are sometimes the most interesting projects, is when things don't turn out the way that you're expecting. But it's a difficult field because you always have to be looking for something new.
Yes, thank you so much. So our next question is, how do you balance work life and your personal life?
I think that's a very common and difficult question. It is common because being a professional like us, one can imagine that during at least the 5 days of the week, we are very busy. We leave very early in the morning from house. Most of the time, my kids are sleeping while I'm leaving from the lab, for the lab. And by the time I arrive home, they are ready to go to the bed, almost. So it is challenging, but it is rewarding also. It is not like, it's rewarding in different ways, almost every possible way one can imagine. So it is difficult, but I think we are able to manage it, like we're able to find a balance between work life and family life. Things are complicated in the beginning when you start your career, like, because you have to earn your place. But once you have earned your place and things are settling down, then you find more time for your family. But it doesn't mean that we have to ignore our family while we are trying to establish, like, while we are new in this career. There is always like a time that we can give take care of the family also. It's not like I would say that in fact this research career is like much better than many other careers in terms of the ability of time that we can give to. These days, I will say that most of the careers, no matter if you want to go to med school or want to be a researcher, they're all very demanding. They're all very demanding. So you have to find, but I would say they are difficult in the beginning, but once things are settled down, we can find a balance between family and, but I don't think it is possible without having a great team. In our lab, our team work in nice harmony. We understand each other's needs. Sometimes one colleague has to, go for some appointment for a family member, for a kid, etc. Others, they are always ready to back up. I take care of your work, doesn't matter. So, during if we have to take a day off, 2 days off due to sickness, etc., teamwork really come into play. So I don't think that's like very difficult to balance work life and family life once you have a good team, and once you show the commitment also, because then you do those same courtesy with other people, right? So it is going not that bad. It's okay.
Thank you for your words of advice regarding that subject. So our next question is, what was the biggest success that you have accomplished as an individual and as a team?
I would say that whatever we have achieved as a research lab, I think that's a success of the whole lab. As an individual, I think I am proud of all the success that our lab made so far. For a new lab, the challenge is always to find the funds to support those research projects. I'm so proud that within the last 2 years, our lab has brought in, I would say, about $1.2 million in the lab as a source of funding. And that I am proud of. But that was not like an individual success. That was a success of the whole team. Our team produced strong, interesting preliminary data that convinced people to give us money to support our research. So I think being a new researcher, that I am something very proud of, that within 2 years for a lab to bring that much of money, and because now we have that money, we can support our research, we can, support our students, we can pay them, we can, do like as many expensive experiments we wanted to do. So at this career stage, I think I'm proud of that success. And in terms of our research finding that I already have shared, but I believe that that's not my success, that's a success of the team. So right now, all of us, we are very happy with the progress of the research and with the success of our grants, research grants to support our research. So that's I would say, and if you wanted to hear on my personal note that what I feel proud of, I think being an assistant professor at the university, leading a research program, comes up with lots of responsibility, but sometimes you feel very lucky also that you are leading people who believes in you. But it's a responsibility also. I feel proud, but at the same time, again, I will say it's all because of my team. It's because of their support.
Thank you so much. So our next question is kind of tailored towards Dr. Sharif and Emma, which is, what was the most important lesson you learned from Dr. Patrick Lee?
Dr. Patrick Lee, if you want to hear the honest answer, I will say that he was like a strict grandfather, an old-fashioned grandfather sitting in a room with perhaps a stick in his hand, and you will enter to his office, you will go to his office and you will tell, okay, this is my productivity of the day. He will analyze your productivity with a very close eye like this. And anywhere if he finds something that he sees that you haven't worked carefully, or you was not smart to understand that, he will not spare you. This was something we learned from him. He was so honest that when he is angry from you, from your research work, he will not hide. Right away, without any, twisting things, no, straightforward. He will come hard on you, hard. He will just, I remember one time I went to his lab. I was very young at that time. You can imagine about 7, 8 years ago. So I went to his office with some results that I believe were very interesting. And they were. And he asked me, do you know that after looking at this particular molecular change, what you expect next? I said, Patrick, I didn't thought about it yet. And he said, next time, don't come to my office half prepared. Come fully prepared, okay? And I said, well, okay, that's fine. So the one thing that we learned from him, straightforwardness, that he will never he is super angry with you. So and second thing that I learned from him is thoroughness. He liked to see the things thoroughly. He says, don't try to cut the edges. Don't find the shortcuts. be like thorough in your research. There are people in the life who try to find shortcuts. No. And he always say that there is always space on the top. Try to be on the top. Don't try to be in the middle. So try for the best. So this is what our research is like. I think we are following that what we learned from him, thoroughness. We want to understand really that if there is some change, why is that? So I think these are the two to three main things that I learned from him. The straightforward, level-headed personality. He will never pretend. When he's angry, he will show you I am angry. When he's happy, you can see he's happy. Second thing, thoroughness. He wants you to be thorough. And third thing, don't try to find like the shortcuts. Go hard.
Yeah, I guess I don't have too much to add. So Tanveer worked with him a lot more closely than I did. By the time I came to the lab, he was getting a bit closer to retirement. So he was on some sabbaticals for some time. But I remember whenever he came to the lab, he was right back into everything. He wanted to know everything that was going on. And just his excitement for everything. It was very inspiring. He would get so excited about all the good data, and he would run around the lab asking questions and trying to understand things even better. And he even today, we keep in touch with him. He gets very excited about any good news or any exciting data. If we send him a short line and just, to keep him updated about what's going on, he loves it. So he was very happy, excited guy when he wasn't being strict, but near the end, he was more excited and things. He just, he really loved research and he really loved the excitement of it. So that was always very inspiring. And I remember he was also very committed. He was at the end of his career and everything. He had a very successful career, but I remember one time he was in the lab and I was there late finishing some experiments or things. It must have been near 8 o'clock at night. And he was still in his office, just reading and working. And I just kept looking over and I felt bad. I said, he's working so late and, he has his family and everything at home. And I was finishing up and I said, I don't know if I want to leave the lab before him. But yeah, he was very hardworking until the end and very inspiring, motivating guy. So that's was my experience.
Dr. Lee definitely seems like he has lots of character and definitely is a really good mentor and definitely clearly taught you lots of lessons. So just as our last question, do you have any final quick words of advice for the students in our audience?
Well, first of all, thanks for having me, because we talk with scientists a lot. And when we talk with the scientists, it's like a fight. We argue a lot. If someone from outside will come into the discussion when scientists are in a meeting or like when they're presenting data, it's a total difference. It was very friendly today. We enjoyed it. So my final words would be that don't please think that research is a hard career. In any field that you choose in your life, without commitment, without hard work, you can't prevail. You have to to have a character and you have to work hard, no matter what career you choose. You go to like a med school, or you have to work hard. Everything is very competitive these days. So don't think that there is no space in research. I never saw a single researcher who is committed and hardworking. He don't have like a successful career. 99% That means almost 100% of researchers that I know who are hardworking and they were committed, they have excellent careers, excellent careers. If you say that success is making money, they made tons. If you think that success is fame, they had a fame. My mentor, Dr. Patrick Lee, until people will use that virus to treat, Rio virus to treat head and neck cancer, that's a treatment of choice. That virus is a treatment of choice for head and neck. People will remember him. If you Google him, you find him on the Wikipedia, right? So hardworking, what I'm saying that in research, there is everything. If you want to choose research as a career, please, if you are committed, well, first ask yourself that, can you commit? If you can commit, I think research is a very exciting job. At some stage, I have many, I don't want to say that, I'm not counter-arguing that being a doctor or being a physician is a bad job. I have colleagues, we have a mix in our department of pathology, we are a mix of people. We are researchers, we are like physicians. And there are many, I know many physicians who are tired because they have to do every day almost same thing. But there are some researchers who are tired too, you know? So don't think that research is a bad, like difficult career. Okay, that's the number one thing I would like to tell. You know, there is tons of opportunities in the field of research if you want to come to this field. And second thing I would like to say that I would be not very hard to make a strict choice. I will give a try first. There are options. You can go to labs for 6 months. You can check how the things are. Like Helgi was mentioning that, you know, try different out things and then so that would be my best. And don't get disheartened. Once one door closes, 10 different doors open, right? So you are in such a stage of your career that, you know, don't think that, oh, I missed out this and that's the end of the world. No, 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 no. There are things that, like, I mean to say, might be even better than what you thought, right? So that's what I learned from my career. Sometimes I was very disheartened in the beginning from, you know, some things that didn't turn out the way I like. But I think then I realized that maybe that was for good. Okay. So please don't think about research like it's hard. It's not. If you are committed, there is lots of opportunities. And secondly, that have some flexibility. Don't like be too rigid like in your choice right now. Give some time, you know, explore a few things, and then you will see that you will find out something that fits your interest. Thank you.
Also, I wanted to add that surprisingly, it applies not only to research, or I guess it also applies to university education and everything. Sometimes you feel like you're already on edge, like it's so hard and everything, but then you usually find that more you push, the more you can do. And you may need to like change some of your activity, find yourself some hobbies, maybe some sport. And even if you feel like that your day is already full, you can't fit anything, but if you shift a bit, you do some more push, you add something more in it, and surprisingly, you find out that you manage it more, and it's getting more rewarding if you can do it. Yeah. So even if it feels hard, once you are in there, it's getting better and better as you go.
Yeah, I think that those are all great words. And yeah, like Tanveer was saying, you don't need to be so set on your path and sure about what you want to do. It's great to explore, and you know, you may actually find something that you didn't expect. I never would have expected to be here when I was your age, but now I am so happy and thrilled at where I am. So it was most of the points in my life where I was upset that things didn't go the way that I wanted to. I didn't, you know, get the scholarship I wanted, or I didn't get the job that I thought I wanted. And then, you know, something better turned up, and then I ended up exactly where I was supposed to be. So just keep open, keep exploring, and you'll find what it is that makes you passionate and what it is that you love to do. And as long as you keep working hard, you will succeed in whatever it is you want to pursue in life.
Thank you so much. And on just on behalf of Project Pulse Winnipeg, I would just like to thank all three of you for your truly inspiring and memorable words of advice. I know that I'll definitely be carrying them with me for the rest of my life and as I enter university. So thank you so much for your expertise and your research as well, and just answering all of our audience's questions. And in addition to thanks for you guys, I would just like to extend our heartfelt thanks to our audience as well for making this event a success by registering to attend and asking your truly insightful questions that are stimulating these like really inspiring words of advice and discussions that we've just had in the past hour and a half. So thank you so much to both the panelists and our audience for making this event a success. And yeah, that's my final words for this panel.
Bye-bye, everyone. Good luck.
Thank you.
Thank you so much for coming, everyone. And just looking ahead, we expect to receive the waiver forms of those who had their cameras on promptly. That's all I have to say, though. Thank you so much for coming, everyone. Have a great evening.